Right, we have 3 teams remaining, and this is a 2-person team called the Dependent Variables.
Thank you. We were originally going to go with the codependent variables, but we weren't sure if that was allowed. So of the 3 topics we were given, and I was supposed to answer why we chose the first one. There's a very technical scientific reason for that, and that's that me and Owen are in a class at UNF, and we were told that if we participate, we would get credit for our final project. And this was the closest thing to what we were covering in class, which is just regression methods. So our approach was a little bit less ambitious, I think, than some of the other participants, but this is what we came up with. So most of our time was spent actually just kind of arranging the data set. We were given I think it was like 27 files up front for different cities for a lot of different census data, kind of like everybody else has said. And our initial goal was essentially just to kind of get everything into a flattened data frame so that we could, didn't have a bunch of NaN values sitting around in it. We did see at the beginning that there were years, and I got a little excited. I thought, okay, well, maybe we'll get to make some velocity and like acceleration type data points. And realized very late in the game that we kind of start, around like 2017, and most of it is aggregated. It's 2017 through 21 or something. On the other hand, we did end up, we were able to figure out at some point that the GeoIDs separate the data into, which is place and tract and stuff, but it's basically state, city, and more or less like tractors at code level. And we were asking the document to go to the tract level, so that's the only real data set that we ended up working with. So what we ended up doing is basically taking a bunch of values. Each of the data sets had a total count for the houses, and they also had counts for other things, like how many houses are in the overburden categories, how many houses are on SNAP. I think we accidentally duplicated a couple of percentages, but essentially what we ended up with is we took the total houses and then say like house for category X, like how many are on SNAP, how many have problems. Problems is sort of broadly defined. I think it was something like disrepair or number of people that were like below a certain income level. Overcrowded, vacancy percentages and things like that. And we ended up getting this data set of percentages, so everything was roughly at the same scale. That was kind of the goal. We then took those, and like a lot of the other teams, we ended up doing principal component analysis so that we could kind of have one index measure to look at when we later would go on to do the regression. These are the weight values that we got out of the PCA process. So overall excessive cost percent and SNAP percentage, both. So there was a USDA and then there was a separate one that also kind of measured the same thing. So we weren't sure if that should overlap or anything. So we kind of left them both then. I should note at some point that the federal, I think it's like the housing assistance numbers. So they would give a list of how many houses in this tract are, within 5 years set to leave assistance, and then how many within 1 year. We didn't know if those were mutually exclusive or not. So we assumed that they were. That's a big assumption that went into this. And you can see like estimated subsidized housing percentage is kind of where those fell into. I'm not sure if that weighting would be affected if those were not mutually exclusive and what we would need to do to kind of pull them apart. But I just thought I should mention that. Next one. So we kind of did a post hoc just to check, do the correlations match up with what the weightings look like? If you put a bunch of, the weightings say put so much garlic in, do you taste garlic after the fact? Most of the weightings do correlate pretty highly, which is what we expected. But it was just good to kind of check that and see what happened. After we did that, we were able to, thankfully for all the early work, we were able to easily re-ingest all of the data frames, not just for Jacksonville, because we kind of started with just Jacksonville. And we kind of looked at all the different cities. I don't know what's going on with Memphis. They might need some help. But Jacksonville kind of fell in, like the median around Jacksonville is roughly in kind of the bottom of the set, like what a couple of the other percenters had where Jacksonville's kind of like in the bottom 5 or something. So I think that's a good sign in general. But the variance is also kind of about this, a little longer than the average, from what you can tell, or at least very like slightly above. But this just kind of gave us a general measure where Jacksonville currently falls in using that displacement index measure. The index itself, goes from 6 to -6. That's my fault. I forgot to re-normalize afterwards to get it like between 1 and -1. But 6 is more displaced. -6 is like least displaced. And then this just shows us the index values for each tract, like how many tracts fall in to each value. So we did get normalized data, which is why we decided to do the standard regression. So again, it was a good sign. We also tried to do some form of map. We vibe coded our way through most of this, so we didn't quite get this to work very well. Our eventual plan was to click on a tract, use the regression values, and plug in, by amount, how much you want to change each value, and see, with other values being held constant, how much you should expect the displacement index to fall or rise in that region. So it didn't quite work out the way we wanted to, but we did make an attempt, for what that's worth. Go ahead. Now, the downside is we did not get a lot of extra data brought in. We were told at some point that before we do that, we should ask one of the mentors. We got past the data step around 6 or 7 p.m. yesterday, and we couldn't quite find anybody to, hey, what are we allowed to bring in here? So we just stuck with what we had. So if I had a asterisk or a big regret, it's I probably should ask for more indicators up front that we can go back and test on, because most of the ones we ended up going into the index. We had 5 left over. We put them in kind of an all flavors at once mix. We scored a 1 for R squared, so good news, we solved the housing crisis. Obviously not, so we had high multicollinearity between the variables. We dropped 2 of them. One of them, the census housing overcrowded housing units value, which is also obviously more or less part of the index. That still has a VIF of around 7, but it's under 10, which is what we were always taught was a good cutoff, so we kind of left that one in there. But of the values, our top one, with the highest coefficient, was the no vehicles percentage. So I don't think it's a big surprise, but areas that don't have access to transportation tend to be high on displacement. They don't have a lot of control over when and how they work and things like that. Our R squared was moderate, so about 0.34. Sorry, yeah. So not high, but at the same time, we only had 3 variables. We also dropped the other 2 out, and it dropped down to about 0.26, which I feel like is still pretty good for a single variable. But we left these in because of that. And we ended up with this equation kind of down at the bottom, where subsidized homes is a count, so you can literally just increment by homes. And the same thing with overcrowded housing units. The percentage of no vehicles, right, you would have to put 0.01 for however many percent you wanted to raise it. And so basically the estimate is something like the index shifts by about 1 in 20 for every 1% change you have in the no vehicles. So but the way I kind of looked at that is, if the top of the index is 6 and you gave everybody in that zone a car, they would drop down to 0. They would go immediately back down to the bottom, assuming that that the regression fits really well, which is kind of questionable by the first one. So then just kind of the post-hoc analysis, we looked at the residuals. Most of, I can't quite quote offhand what all these indicators mean, but we kind of look them up as we go. Durbin, Watson, Omnibus, and the skew and kurtosis values tell us that it's roughly normal, and then the QQ plot just kind of validates that. So the residuals were normally distributed, which is what we wanted, and so overall the regression fit is good, even if the R squared isn't too high. And that's basically where we stopped. So I'll leave it at that. Any, questions?
No, I think you're asking for it.
I think we're good.
We're good.
Thank you, guys.